and then how the blind search and the breakfast source works, and how are they going to check the repeater state, and also how the agent, when the agent is going to end. Yeah, so we have to check the open or the closes for the breakfasts, and we only check the closing in the breakfasts. Then we have the heuristic search here, which we covered last week. Okay, we have a three main algorithm here: hill climbing, best first search, and also the A star. So A star is slightly different, is where it's not depending on the heuristic cost, but also depending on the GN. This is the path cost. Right, what is the GN? It's actually a total step cost that between the initial state and the current state. Okay, meanwhile the hill climb, steepest ascent, the bestest all depends on only HN. It's only depending on this value. Okay, so you still don't know how to get this HN. It actually came from the heuristic functions. We are the ones who design the heuristic functions, and the agents will perform the move according to the heuristic function. They will do the ranking, yeah, to do the sortings, which one is closer to the goal state, and the agents will explore that particular path. Okay, and then there is a hill climb, simple hill climb, a steeper ascent hill climb, as shown in the left hand side here. Right, so the simple hill climb is work like a depressors, explore only one directions. Right, as long as the tail node is better than the parent node, then the agents will continue to move. Otherwise, it will actually move to the neighbor's successor here. Meanwhile, the steepest action is like a breakfasts, is expand all and compare which one is closer to the goal and also better than the current state, and will expand. And always remember the limitations for the simple hill climb on the steepest action hill climb is not allowed to revisit the previous nodes, causing in the local maximum, which we will cover last week already. Okay, and then this is the summary for the best person and the steepest ascent, best person and also S star search. Okay, so in case you cannot remember the rules, so I already put it for you, so you can just download these documents just for your revisions. But just bear in mind, I'm not going to ask you like this. Okay, compare between breakfast and breakfast, then you show me this note. So what you have to do is you must understand how to get these three things, which is how to get the search tree, draw. You must know how to draw a search tree and must know how to get the return path and also the search path from the search here. Okay, which I already covered throughout these so many weeks, right? So I'm going to show you the cannibal missionaries. We have sliding house, and we have a state space. We have a map problem. I already show you quite many examples, right? So make sure that you attend your tutorial class and make sure that you know how to do the expansion or the blind search and the fusion. So this is the very famous questions in both midterm and also finals. Okay, alright, so that's it for summary for the previous three chapters here. And let's move on to our new topic, which is chapter number 5, which is known as knowledge representations. Okay, so what is knowledge representation? As you know from the topic here, knowledge representation means that how are we going to represent the knowledge? Okay, knowledge representation means that how are we going to represent the knowledge? How are we going to organize, store the knowledge so that the machine can really understand the real world, interpret from the knowledge, okay, and make decisions so that it can interact with humans. Okay, so again, what it means by knowledge representations is a way, or is this a tool? Just a tool to represent the knowledge so that the machine can behave just like a human, understand what's going to happen in the world, and also interpret, make decisions so that they can communicate with the human. Okay, so there are many tools that can represent the knowledge. So which are semantic networks, conceptual graph. Semantic network and conceptual graph, these are the two common tools that used to represent the relationship between the concepts. Alright, so quite many of the applications are using semantic network. Google is used, how do Google know the relationship between one object and another object? So they use a little bit of these semantic networks to retrieve the relevant information to you. We have NL graph, so this is the graph that used to represent mainly the rules. Right? So we want to represent a rule so that we can actually so-called reasons, or what is the conditions that cause their particular decisions or the solutions here. And the last one is the frames. Frames is just like the class diagram that you have learned in object-oriented. Right, so you have a frame, you create a frame here, then you store the object, and you store the slot, and you store the values, so that the machine has a certain kind of properties. Right, so we have two so-called methods here to represent the relationship, and a graph to represent the rules, and the frames is mainly represent the properties of one object. Okay, and so later on within this, I think just 1 hour class, we are going to cover how to draw this semantic net, how to draw the frames to represent a particular knowledge. So this is kind of a planning stage. It's not yet go into the coding. So it means that we have to do the planning phase before we put into the coding, so the machines equipped with that kind of knowledge. All right. Okay. So give you some ideas how it actually works. For example, if you go to Google, you type what is book, you type a particular words here. So sometimes you may see the so-called the response. They give you some other links that's not relevant to the book, but it's actually a book, but it's not a keyword book here. For example, the novel. So how the machine is understand so that the book is there's some relevancy between the book and the novel. So it's based on the so-called. This is actually not WordNet. WordNet is a part of the semantic networks. So you can see there's some relationship between the novel and books here. That's why, although you didn't write the novel here, the machine is still able to return the response that related to the book, which is the novel. Okay? And then how the hour, you will type how the hour, how the machines know that it's actually equal to 30 minutes because the machines that has some relationship right, in the back end there. Right, so half an hour is actually has a relationship between 30 minutes. Right, so always remember the machines, it's not like the humans. Right, humans, we read the books, we equip the knowledge, but the machine no. But how the machine equip the knowledge, most of the time they through the relationship. We have to build a relationship so that the machines will know that, oh, what is the relationship between this word and this word. Okay, then they will respond accordingly. Okay? Alright, for the newcomer, right, so sit down and please remain quiet. Right, we already start our class. Okay? So in these two topics, chapter 5 and chapter 6, there are many related to NLP applications. Right, NLP application. NLP stands for Natural Language Processing. I think that this is not it's a very common term right now. So you know what are the common applications for NLP? What's the mean NLP? NLP stands for natural language. What is natural language? For example, English, the language that can be used in daily life. English, Chinese, Tamil, Malay. So all these are natural language. Processing, so it means that we are going to process the natural language. Why do we want to process the natural language? So that machine can understand. Natural language understanding, so that the machine can understand human language, so that it can generate the correct response. That's it. Right? So NLP consists of two parts here, NLU and NLG. So natural language understanding is how the machine understands a particular question. Like you're querying a Google type of question here. Your type of question is, what is automobile? A very simple question here. But you have to bear in mind the machines is not like the humans. We know, okay, automobile is actually a car, vehicles, four wheels. How the machines understand this? If the machine cannot understand these questions, then the machine cannot provide a relevant link to the user. So the first thing, the machine have to understand what does it mean. So in order to understand all these words here, so the machine has actually processed a lot of so-called pre-processing first. Okay, some of the common pre-processing is like, for example, tokenizations, alright, remote start words, okay, and then we convert to the lemmatization, standings. All this you will learn in your practicals 4, which is NLP. Right, so we have to do in the back end actually a machine has do a lot of pre-processing so that the machine able to capture the keywords. So that is the first thing. Machine have to identify the keywords first. Yeah, your question is different than different user. Right, your question may be what is automobile. So another maybe is what is car. Maybe you type in Chinese, you type in different languages, and you put different sequences. Right, so we have so many types of questions, but actually we are asking the same things. So how the machine actually identify what you're trying to ask? So the machine has to do a lot of pre-processing first, identify what is the keywords. For example, in this case, what is automobile? The machine will perform a lot of pre-processing first. Yeah, standing, lemmatization, stop words, tokenizations, part of speech tagging, and then entity recognition. All of these you will learn in your practicals. So after machines perform all these things, which we will cover in the chapter 6, is known as the NLU. The machine have to understand first, right? So once the machine understands the keywords, add the keywords here, the machine will have to further understand what means by automobile. We want to understand what is the meaning. Okay? In order to know what is the meanings here, we need to provide some knowledge to the machines. Right? So this is in the chapter 5, the machine will try to understand the meaning. Right? So this one is just to understand and identify the keywords, but then afterward the machine will start to understand the meaning through the relationship, through the frames, attribute, and so on and so forth. Okay? So one of the examples here is we use the semantic network. Let's say there is some relationship between automobile and the car. Alright, so automobile car has 4 wheels, for example. So we have to represent all of this knowledge to the machines. So the machine will identify the keyword automobile, then you will come to here, there's a relationship between automobile and the car, so that it will actually return the relevant link, not only automobile, but also the link about the car back to the user. Yeah, you have to only remember the automobile, maybe it's not a very famous keywords here. So the machine is still able to understand automobile is actually relevant to the car, then it will return maybe the links or maybe the YouTube link or whatever back to the user. Okay, so if let's say without providing the knowledge to the machine will basically just do pattern matching. We'll just identify what are the links, right? What are the information that only related to the automobile. You will just capture, match the patterns, and return the relevant link back to the user. But this is make the search become not effective because you may miss out some important information that related to the automobile as well, for example, the car. Okay, so to make the search is more effective, more smart, so we have to keep updating the knowledge. Okay, alright, so that one is too deep already, too far already. We have a lot of ways to represent the knowledge. We have a semantic network, we have a word embedding as well, which is beyond the syllabus. So I will just cover a very fundamentals. If you want to know more about this NLP, NLU, NLG, then you should choose the elective course. We have an NLP course that offer to you guys. Is it elective course? Yes, NLP. Yeah, it's elective course. No, it's not offered to RSW. Okay, maybe it's only offered to RMTS. But I heard it's already offered to business students for FLB. So I believe that it's sooner or later it will offer to you guys. Maybe next semester one, follow you will. You want to know more about how machine understand the words and how all these relationships, how to build the word embeddings from scratch, then you have to attend that elective course NLP. Okay? Alright, so but this topic here, chapter 5, I will just teach you how to do the planning, how to draw the semantic network frames and the other, that's it. Alright. Okay, just like for you guys, you have learned about the object-oriented, right? You have what is UML? Unified. I can't remember already. Yeah, you will draw a class diagram here. Yeah, for this software development life cycle, so you draw about the DFT diagram here, right? Data flow diagrams. Right? It's just like how to represent kind of a knowledge, so that we can pump into the machine, so the machine will interpret, understand based on the the planning based on the knowledge representation that you have provided to the machine. Okay, so that's it. It's about chapter 5, just like how the machine is trying to understand some keywords that extracted from the chapter 6, which is the NLU. So NLU is more about process. How are we going to process a keyword? How are we going to process a string so that machine can capture the keywords? Right? Machines cannot behave just like human. We understand grammar, we understand human language, right? We understand, okay, I give you a flower, I give you a pen. Right? We understand that I'm passing a pen to the user, but machine can understand. So we have to perform a series of processing so the machine can somehow understand this sentence. Okay, so we will cover next week later. Okay, let's start with the first tools, which is the semantic networks. Right, so what is semantic networks? Networks is like a spider net. What is semantic? Semantics means meanings, the meanings of the word. So we try to build a semantic network, means that we're trying to build a network that connects all of the words. Yeah, all of the words here. Right, so usually it's very simple to draw the semantic networks. Only 3 things that you have to take notes. The first one is about the concept. Right, so you have to draw a note here, and then you have a concept here. So let's say this is concept 1, so you have a concept 2. Okay, so that's the first thing. The second thing is you make sure that you draw the so-called the arc here, the lines. Okay, concept 2 somehow relate to the concept 1. Okay, so that is second thing. The third thing that you have to draw is the relationship, the labels. What is the relationship between concept 2 to concept 1? That's it. As simple as that. For example, yeah, G-Dragon. Anyone went to the concert last week? Cannot buy a ticket. Cannot get a ticket. Okay. So what is the relationship between G-Dragons and maybe Big Bang? Member of, right? So it's a member. So you just write a member of. Yeah, member of. Yeah. So what is the song from G-Dragons?
Bad boy.
No G-Dragon fans, huh? Yeah.
Tôi don't like.
Not home sweet home. Okay. Yeah. So that's it. So you have a note to show the concept here. You have a so-called the line arrow here to show point the relationship. Then you have the label art song here. As simple as that. Yeah. Okay. So let's see some examples here. Okay. So from this simple semantic network, that we will know that human is right? It's means that you are a subclass. Human is kind of a subclass to the mammal, and human has nose. And Simon instant. Here I'm not going to use instant. I'm going to use instant because it's an example. Simon is just an example to the human, but Simon is not a subclass to the humans. Simon's favorite number is 8888, and the Simon group is in L1. That's it. As simple as that. Right. So normally you are given a sentence here, or maybe a paragraph. Then you have to draw a semantic networks. But somehow, students still always lost a lot of mark in this kind of question. This kind of question is kind of bonus. You are not required to have any technicals, any what kind of knowledge to draw. You just need to draw a notes here and you point a relationship, put the label arcs here. Okay, for instance, you have a Shin-chan age 5 years. Forget about this, so this is the first order logic predicates here. So it's out of our syllabus. If you are from diploma, you have probably learned about what is your predicates here. But just don't worry about this. Just look at this sentence here. Shin-chan is 5 years old, so we can just put these 2 concepts. Shin-chan is 5. Shin-chan age is 5 years old. That's it. Yeah. 3D, the birds can sing. So 3D is the examples to the bird. 3D can sing. If you don't want to put can, then you can just put ability. Ability sing. That's it. Yeah. Okay. So. Can you spot what is the errors or what is the mistake they make in this line? So this is a simple semantic network as well, but can you spot the mistake, the errors? Yeah, Jian Quan. Okay, very good. So you miss out the relationship here. Yeah, so you should have a. What is the relationship that you put? Fish. is a subclass to the animals. Ostrich also is a bird. Curly also is a bird. So you based out the so-called the relationship. Any more? Sick. Not really. I'll ask you. Anytime? Can you spot any mistake beside these
去
two?
买那个狗力了。
There's one more mistake here.
当时才能搬，有啊有，有，还有没有？对。
The error, very good. So the errors here is missing. So you should point or trick to the one here. You cannot just leave it here. You should point error, the directions of the errors. Very well done. Okay, so can you try this or represent the terms below in one semantic network? Edward is a vampire. Edward's girlfriend Bella is a human. Jacob is a werewolf and he is about a child's brain. Werewolf is the enemy for vampire. Alright, so usually you're given a paragraph like this, then you have to draw the semantic networks based on this simple paragraph here.
Vampire，这叫什么小啊？这名？Werewolf 啊，Twilight。
Okay, so we will always start with the first sentence. Edward is an vampire, right? We just throw Edward. So we have a second concept here, vampire. So what is the relationship between Edward and the vampire? Edward is a subclass of Edward is an example. Example, right? Example. So it's example, then we put instant. Right? Instant vampire. Very good. First sentence done. Edward's girlfriend Bella. So you have another concept here. Bella is a human. So we have Bella. We have human. Okay, so Edward's girlfriend. So what is the relationship between Edward and Bella? Is a boyfriend to or is a girlfriend to? It's up to you. You can put the boyfriend to. Edward is a boyfriend to Bella. So Bella is or instant. Instant is the example. Instant. Okay, done. Second sentence done. Let's move on to the third one. Jacob is a werewolf, and he is a Bella child friend. So again, we have a Jacob and a werewolf here. So again, I'm going to draw Jacob. So we have a concept werewolf. Okay, so again, Jacob is just an example. Instant. But there is a relationship here. He is a Bella child friend. Right? Okay, last one, werewolf is the enemy to vampire. Werewolf is the enemy to vampire. So enemy to. That's it. So as simple as that.
Simple.
Yeah, as simple as that.
What's that?
Then you score full mark already. Score full mark already. Unbelievable. So usually this question 2 is a bonus mark for student to recover lah. They lost a lot of mark from the question 3 and question 4 especially. Then this chapter especially is just to cover the mark that you lost in the question 3 and 4. But that is the way that how we represent the knowledge using semantic networks. So what is the advantage for using a semantic network? There is no standard way. You can just put so-called child friend, or you can point back and child friend, boyfriend to girlfriend to, is up to you, as long as it's logic and it makes sense. Okay? Make sure that you have a direction here, and then you have a very clear label out and show the relationship between two concepts. That's it. Okay? You see? Yeah.
Can you see me?
Okay, good. So let's move on to the next question. This one is really challenging here. Sometimes you're not required to understand the meaning as well. So you just need to assume that it's just a concept, and you just draw a line to represent it. So look at these questions. So perhaps I give you maybe 3 minutes Yeah, 3 minutes. See whether you are able to draw the semantic network to represent this story as well when traveling to a new place. So there are options of staying in a hotel, farm, or homestay. The 3 lodgings offer a variety of facilities: water heater, sauna. So there are animals in the farm, rabbits, and sheep are both commons. Homestay, on the other hand, has the share lounge and the free Wi-Fi. Yeah, 3 minutes.
The animal is from. So if 我去 farm 的话，我有 animals, rabbit, sheep, common. Homestay 的话，我有 WiFi 还有 lounge. Homestay, but hotel. If 如果你愿意一层一层一层地剥开我的心。有人做哎，不要玩了，不要等下就没有
Okay,
出
so
息
when
吃
travel to a new place, so there are options staying in a hotel,
不要等下就
farm,
没有
or
出息吃。
homestay. So the 3 lodgings
出息
here.
证。
Okay, so lodgings. Okay, and then you have 3 options: hotel, farm, or homestay.
还没有看到，没有看到。
Yeah, so this could be a hotel, farm, homestay. Okay, so they are example. No, they are subset to the lodging. So they are is a. So how to know whether it's instant? Unless we have another hotel name 888. Yeah. So this is just an example. Then we can put instant. Yeah. But hotel itself is a term. It's a subclass, right? So that's why hotel is a lodging. But this is not inside our paragraph. So I just want to show you the difference between instant and also is a. Alright. So continue. Variety of facilities. Water heater. So facility. So we have facility. Okay, so we have what? Water heater and sauna.
Water.
So usually you have a water heater and sauna. We don't put into one concept. We just separate into 2 different independent notes here. Water heater and the sauna.
哪里来的这些东西？
Okay, so there are animals in the farm. So we have an animal in the farm here. So rabbits and sheep.
Water heater.
Okay, has
Sauna.
maybe animal.
Sauna. Water heater.
Okay, and rabbits and sheep. So we have rabbit, sheep. So they are subclass to animal. Unless you have rabbit A, where you know the rabbit as Peter, then the Peter is instant to rabbit. But the rabbit itself is a subclass. Okay, and homestay. at the other hand, had a share launch and a free Wi-Fi. Homestay has launch and Wi-Fi. Maybe it's free Wi-Fi. Maybe we can just put free Wi-Fi. Okay, so that's it. Yeah, very simple. Hotel, farm, homestay.
A simple.
It's a subclass to lodgings. Farm has animals, rabbits, sheep here. And lodgings offer facility like the water heater, sauna. Homestay has launch and also the free Wi-Fi. Did I miss out anything? No. That's it. 2 marks. Alright. Simple as that. Just remember you have a note, then you have directions, arrow beside the directions here, and the last one is the relationship to labor arch.
kata nama khas phải xứ kata nama phải xứ
Okay, so that is for the semantic networks. So let's continue. Alright, so yeah, this is another example where rover the dog bites the Peter. The Peter is the postman, right? So the rover bites the Peter. Peter is an example to the postman, and the rover is an example to the dog. But sometimes we can expand this event. So this is the action here, but we can expand or extend this event to a node as well, a concept, which is what is the concept now. So previously it's just to show the label arts, but now we can extend it to one of the concepts, right? So then we can create another example, for example B. B is just an example to this event, and in this event, who is the agent? The rover. Who is the victim? Peter, because rover but the Peter. So rover is the agent and the Peter is the victim. That's it. So it's just either this one, both are correct. There's no wrong or right. So as long as it makes sense, it's correct, so then you can just proceed. Okay, so this is another way where we represent a sentence with quantifier. So what do we mean by quantifier? Quantifier is where you have kind of words like, for example, every dog, some dog. Right? So this is known as quantifier. So when you have a quantifier here, you have to use partitional semantic networks. So what is partition semantic networks? Partition semantic networks, so you have multiple semantic networks to combine it together to give you a full semantic network here. Okay, so from the sentence, we know that every sentence has a Peter's postman. This sentence is actually a general statement. When you have this quantifier, it becomes a general statement. So this one is not a general, it's a particular event. So this one is general statement here. So when this is a general statement, you can simply just create so-called general statements of semantic networks, and semantic network represent the dog by the postman and join together. Right? Why we put the symbols? This symbol is represent all, every. Right? So the point to this D here means that every dog, right? Every dog bite the postman. That's it. Yeah. So it's just a way to represent a general statement, a quantifier. Right? Okay, so if you have another sentence, every dog has bitten every postman, just point at another line here, at these symbols, all, right? So all dogs bite all postman customers. Okay, so just to combine, to compare two objects here, so we have two different heights. So we just want to compare, just put a line and return. That's simple as that. Yeah. So this place is actually bigger than this place in terms of the height. Okay, so this one is where you have more than two arguments, right? So in previous we have only two arguments. Two arguments when you have only two objects, right? For example, lodging, water heater, lodging, sauna, lodging, hotel. So you have only two arguments here. So what if let's say you have more than two arguments? For example, in this case, you have Portuguese, Morocco, and 01. You have three objects there, three so-called arguments, right? So how are you to represent the semantic language? So in this case, you have to create a node. You have to create a node, right, to think a new words that can link these three objects together. For example, in this case, I can create a keyword called features. Right, so features is a instant, it's a so-called subclass of the football games. Right, so these features actually join the Portuguese, this score 01 and the Morocco here. As simple as that, just create a node, a keywords that can join these three objects together. If you can't think of words or keywords that can join these three objects together, then you can just simply create event 1. That's it. Right? Event 1 is instant to the game, and then you just join these three arguments. Yeah, John gave book to the Mary. That's it. Okay, as simple as that. Alright, so once we have these semantic networks, then the machines can interpret, yeah, just not only pattern matching, give you the keyword, the machine understand what's in the memo now, right? So when you ask the Google, right, what is the memo? The memo will tell you, oh, memo has skin, a memo has nose, right? Human is a subset to the mammal. When you ask about who is Simon, then you will understand, the machine will understand Simon is actually a example to the humans, and since human all has the nose, and then you can interpret as well the Simon has the nose, and so on. So this is how machines or maybe the Google try to understand some information. It's through the relationship. Okay, but Google definitely use more than semantic networks now. It's not only semantic, but they're actually using the word embedding, semantic nets, neural networks, and others to improve their search engines. Alright, so this is one of the common. It's not in the slide, I just added yesterday, so I just want to show you the applications of the semantic networks. So WordNet here is a very well-known tools that are available in the NLTK, available in your package. Yeah, you can just call the NLTK WordNet. So what is WordNet? WordNet is actually a lexical database. It's a lexical database for the English. It's built by a group of researchers in the Princeton University. So what they do is actually they try to arrange all the words in hierarchical way and put their relationship. For example, in this case, right, color. Right, so under the color we have purple, red, blue, and the green here. And then what is the relationship between red and the color here? So red is the hyponyms to the colors, right? Color is the hypernym to the red. So and then purple we can further categorize into violet and others. And in this case, what is temperature? So we have a hot and cold here. So this group of researchers has put all these words into the WordNet. Then we can use this WordNet into Python to build our applications. Yeah, for example, we can use the WordNet to paraphrase our paragraph, right? Because we use the synonyms. For example, in this case, I like automobiles, right? I like automobiles. I love my new automobiles here. So we want to paraphrase this sentence. The machine will understand first what is the synonyms. Love, right? So maybe love synonym is liked, favorable, right? So then it will actually paraphrase become I liked my new. Maybe automobile is also has a synonym car. So it become I like my car. That's it. Or we can use the WordNet to do a lot of things here. To check whether these two paragraphs are the same, to paraphrase the sentence, and so on and so forth. Okay, use as a search engine as well. Okay, so this WordNet consists of definitions, the meanings of the sentence, example, as well as the most important is the semantic relationship. Yeah, why? You can see that most of the time, why we need to do all these things. One of the reasons is we want to have the machine try to understand the word meaning. We do all these things, we do word embedding, we do WordNet, we do so many things, do so many research. The main purpose is just to make sure the machine is trying to understand the word meanings. Because the machine is not like the humans. Humans, we learn, we attend a class, we learn from the past experience, we learn from the mistake, we read the books. But the machine, no. Right? Machine is just like a plain paper, zero. So we try to provide more information as well. So one of the well-known techniques is called as a WordNet. So this is one of the WordNet libraries here. You can just import an LTK and then just download the WordNet here. Then you can see that I try to find what are the words that is quite close to the automobile. So it will show me a lot of synonyms here. Car, auto, automobile, machines, motor cars, and then it will provide the definition as well. Yeah. So the main reason is want to identify the synonyms. When we know the relationship between the words, then we can do a lot of things. One of the well-known applications is, for example, we want to check the similarity. Yeah. For example, in this case, I have two sentences here, maybe too small here. The first sentence is dog bites the man. The second sentence is puppy attacked person. Are these two sentences similar? Not like similar, but how do machines know these two sentences are similar? Right, dog bites the man, puppy attacks person. That's why we can use the WordNet to identify what is the relationship between dog and the puppy first. What is the relationship between bites, attack? What is the relationship between man and the person? From here, we can use this well-known similarity, it's called word similarity. Then give you a quite high score here. It shows what? This value shows that these two sentences are quite similar. Right, so how this word similarity works, it's actually based on the relationship, like in this case. Right, so in this case, right, so let's say now I'm trying to understand what is the relationship or how close purple and red. So we will actually identify how many levels this purple and the red place at. Do they have a common words here? Do they have a common hypernyms? If yes, then we will have to give a high score. There is a formula to calculate this value. This value shows how close is the two sentences. By using a simple one essay, we can build an application to identify whether these two sentences are similar. Right. Another application that we can use is perhaps word sentence ambiguations here. Okay, what is the word sentence ambiguations? Right. Let's understand what is ambiguity first. Yeah. Let's understand what is ambiguity. Yes, what semantic ambiguity. Semantic ambiguity is a word that has multiple meanings. That has a multiple meaning. For example, a very simple one, bank. When we talk about bank, so there are multiple meanings that can refer to the banks. One is to refer to a river bank, the river bank. Another one is refer to the financial bank. Public bank, Maybank, we have CIMB Bank. It's all about the bank that store the money. Another one is about river bank. So when we ask about bank in Google, for example, he went to the bank to deposit money, right? So as I mentioned, we have to do a lot of things to try to make the machine understand what is the meaning of this sentence. Yeah, this sentence here. So how the machine understand this sentence? You see, if it didn't do anything, we just put it into Google. Machine don't do anything. The machine is confused. The bank here, is it refer to public banks, Maybank, financial banks, or refer to the river bank? So what we have to do here is we have to do what's the ambiguation. We have to solve the ambiguity first. One of the methods we can use is using the word nets, right? So we can actually compare this sentence with the definitions between these two meanings here. We have so-called the river bank obtained from the word nets, and then we have also the financial banks that obtained from the word nets, and it came from the definitions together with the synonyms and everything. So the machine will actually compare word by word here. Deposit, yeah, you have a deposit word here. Right, so money, you have a money here. So then the machine will somehow predict this bank here is referred to the financial banks. So this algorithm is known as a LAX algorithms, right? But another way to solve the word ambiguation is using the machine learning. But we don't talk about machine learning, we just talk about the LAX algorithms. So how the machine understands the bank meaning is just by comparing the word by word with the definitions that obtained from the word nets. So now the machine will know already, the bank here is referred to the financial bank. So we can see the output here. So the machine predict the bank here is referred to the container that store the money. This actually referred to the meaning number 2. Yeah. So as I mentioned, without this semantic network, without the word net here, the machines wouldn't know the true meanings of a bank. Then when the machine doesn't know what is the meaning of a bank, then it will return you a wrong information, wrong link, wrong query to the user. So why we do all these things? We have been trying a lot of hard work. Many researchers have been putting a lot of efforts to build a net, to do all these things to make sure the machine try to understand better the human language. Okay. So what is the advantage of semantic networks? Easy to understand, right? Easy to build, right? Easy to draw. Everyone, as long as you have a pen, you know how to draw it, right? So, but disadvantages is there's no standard about the nodes and the args value here, and there's no describe about the attributes. And this is not suitable to describe when you have a lot of properties. Imagine you have a lot of properties, you have a lot of branches here. So to have a better understanding about the properties, we have to use different tools, which is the frames. Okay. So I will stop here for 10 minutes until this stage. Alright, so we should take a rest for 10 minutes, then we will come back for the second tube, which is the conceptual graph. If you have any question regarding to your assignment or regarding to this, you want to know more about the work with this word net, you can come down and discuss with me as well.
完全不懂讲问题。启宏，你们的 AI 讲了。 recommender 啊，你们的 dataset 有超过一个啊，两个啊。OK， 所以你们开始找 algorithm 啊？
我没有打算去买手表，
有，
我要3粒。